Okay, look, Dr. Michaels. We could have another perfect attendance day going. All right, there's Bora, he's always here. Okay, let's go over the warm-up. Let's see, Ian, since you're so kind as to have your camera on, I'm gonna let you take on number 1. A computing device is a machine that can run a program. Do you think that's true or false?
I think that's true.
Correct. Well, we'll see. So here, we'll mark these. Let's see, I'm going to use my fabulous multiple person randomizer. A user. Let's see, let's go to the back of the line. How about Parker Michaels? Can you let me know about question 2? A computing system is a group of connected computers that can send and receive data, a machine that can run a program, a group of computers working together for a common purpose, or a sequence of direct connections. What do you think a computing system is? Parker Michaels? Well, you might be having a mic issue. Let's try Lily Kreindler. Can you tell me what a computing system is?
A machine that can run a program.
All right. Let's do that. I think that sounds good. Let's go with Matthew Glassman. A computing network is a group of connected computers that can send and receive data, a machine that can run a program, a group of computers working together for a common purpose, or a sequence of direct connections. What do you think a computing network is?
A group of computers working together for a common purpose.
Okay. Number 4. Let's see. Sarah Selvraj. A path is a sequence of direct connections. Is that true or false?
True.
True. Okay, let's see how we did. Okay. Here we go. So we only got 2 out of 4. What were our problems? So number 1 was true. A computing device is a machine that can run a program. A computing system is not a machine that can run a program. A computing system is a group of computers working together for a common purpose. That's a weird one. Remember, a computing system is just a group of computers working together for a common purpose. Now for 3, a computing network is not a group of computers working for a common purpose. What is that? Can someone sing out?
A computing.
What is a group of computers working together for a common purpose?
A computing system.
Computing system. So a network, what defines a network is the idea that it's a group of connected computers that can send or receive data. That is the big ticket for a network. A network sends and receives. A system is just a bunch of computers for a common purpose, but they are not sending and receiving data. And number 4 is correct. The path is a sequence of direct connections. Okay, hang on, let me get out of, so that's why she does 2 computers. I'm gonna get out of there. I'm gonna get out of student view, and we will pick up with today's presentation. Come on. Oh, there we go. Leave student view. Okay. Here we are. So if we go into the presentation, this is our beautiful presentation. Let's start out on the first slide. Let me see if I can move this over here. How exciting. All right. My people are taking up too much space. Let's reduce you. Oh, no worries, Parker. Parker's mic wasn't working. Something, if you guys have a mic or a speaker that's not working well, you can always call into the meeting too and use your phone as your mic or your speaker. That's just a little trick. All right, let's go to present and ask the ever exciting question. Are you seeing this in full screen?
Yeah.
Okay. So today's agenda is we've done our warm up in Canvas. We are going to be working on Unit 2, Lesson 4, Routers and Redundancy. If we can get to it, we're going to look at the video for U2L5 on packets. Due today is your warm up and the U2L3 activity guide from last class. Does anyone have any problems with that U2L3 activity guide? Getting that in, what we went over last class. We will review it in a moment. All right. What we're going to be working on today is the U2L4 activity guide. Our objective is that you will be able to explain how routers guide internet traffic using the IP address and interpret the routing of traffic or messages on the router. When we say traffic on the router, typically that is messages. So just want to make sure you're making that connection. Okay, just a note, I know that we have been keeping a relatively fast pace. Apparently some people are feeling a little left behind. We don't want that. We do want to be able to cover what we need to. So if you need more time to understand any lesson we have gone through, please come to the check-in session on Wednesdays. I know we missed a Wednesday recently. Oh, look, there's Juan Geraldo. All right, 1 second. Let me just get him checked in. Welcome, Juan. So we're just going over the basics of the day. So in any lesson, if you need more time to understand what we've gone through, please come to the check-in session on Wednesdays. There is a new Zoom link for the check-in sessions. I hope everyone received my email about that. Now there's going to be one Zoom link for all our Wednesday sessions. So ideally, that will help us. Look, I think we've got everyone. That is so exciting. That will actually allow us to go a little later or earlier if I have a lot of people who are asking questions. If the coming to Wednesday doesn't work for you, just email me. Email me and let's set up a time that we can go over stuff. I don't want you getting left behind. Sadly, what we have been over in this first month and a half is the easiest parts of code.org. So we're just laying the foundations. This stuff should be relatively straightforward for you and make sense. As we get more into programming, things are going to get more complex and more difficult. So remember, I'm here for you, and Wednesdays are a great time to catch up on anything you think you might not be, have a real firm handle on. All right, let's reflect on lesson 3. I looked through some of the rules that you guys produced. So most of the rules specified, so remember last Thursday, we were on a widget that broadcast your messages. You wrote a message, it went out to everybody that was in your group. So most of the rules specified the person that the message was from in all the sample messages. We were trying to make our schedules. Everyone learned if you didn't put your name on your document, nobody knew who the message was from. Some of your rules specified the person the message was to in all the sample messages that were posted. So the idea is, it seems like a lot of people felt that having a to and from address on your message helped people understand what was going on in terms of who is trying to schedule what when a message is being broadcast. Some had one person schedule first, put their schedule in first, and then proceed to the next person in the group. Some had a schedule that was changed each week to move the meeting to the next day. That was people who were looking forward and trying to anticipate what the demands of the worksheet were. That wasn't necessarily the best move for learning how the routers were working. Some groups had a way to ask if a person was free using binary code. That's pretty cool. And that seemed to help them. One last idea. Very few students had a rule to let other members of their group know that they had finished their schedule. So like, my original idea for doing this was to have one person, create a leader of your group. That was another rule that we did come up with, was the idea of having a leader of your group. They set their schedule, then they pass it to the next person to set their schedule. It's going to be easy for the first couple, and then the last person is going to have to figure it out. Did anyone else have any other rules or things that seemed to help them in setting up that schedule in lesson 3? Does this all bring it back and make sense of what we were trying to do to improve our experience working on the broadcast widget? Okay, everybody seems happy with that. The main takeaway from lesson 3 is that the internet is like the post office. Let's think more about this analogy in the prompt for today. Okay, today's unit 2, lesson 4, routing and redundancy. You might as well get your code.org open. We're going to be going in here in a minute. To start off with though, we want to look at the end of our last class, we saw that the internet uses the internet protocol and IP addresses to communicate across the shared internet. How is this system similar to how we send letters in the mail? How is it different? Let me just call on a couple fun people. How about Dennis Softing? Can you tell me something about what we were doing yesterday? How is the internet protocol address, how is sending messages similar to how we send letters in the mail?
Basically, the IP address is your online, it's the address for your computer. So through the mail, you would send an address to a person's home, like you'd send the street name, the house, the zip code, the city, the state. But for computers, there's the same thing, but with different numbers. So each computer has an IP address, which is a certain set of numbers which act as a address. Right.
And how is this system different? So it sends things to an address that starts big and then gets smaller. So it starts with, city, then, name, then street, then that way. How is this different than the US mails?
Still me?
Yeah, you did so well.
The numbers, they don't mean the same thing, I'm pretty sure, right?
No, they do not correlate one to one to the name, but they are telling similar information. Let's branch out. Hang on, let me expand my world. How about Ryan Weiner? Can you tell me a way that this system is different than the US Post Office?
The U.S. Post Office is much less direct than what the internet is. The internet is pretty much automatic, whereas the U.S. postal system takes a lot longer.
Okay, now that's interesting. So let's say, I think you will learn today that our system is much faster, but it is not necessarily more direct. You'll see today with the router. Other things, hang on, that are similar, it's the idea that one involves paper, the other's an electronic. There, a fair amount of, differences. But it is a very similar system. You are sending an item to an individual, you are addressing that item and hoping that they're going to receive it and respond to you. Okay, so in our last lesson, everyone was directly connected to everyone else, and we could see all of the messages. In today's lesson, we're connected to a router, which helps decide which messages we receive. We can even take a look inside the router to see the decisions it is making. All right, so we're on an updated internet simulator. We're gonna go into code.org. We're gonna go into lesson 4, and we're gonna open our internet simulator and connect to a router number. There is a limit of 6 people on a router. Make sure all your messages you send today are appropriate for school, or as I like to say, so that your grandmother could read them. I will be able to read all messages and identify exactly who they come from, is the reason this notice is being given, because apparently inappropriate message sending happens. So step 2, say hello, use the updated version of the internet simulator to send a message saying hello to everyone in your group. Everyone now has an IP address. This will be important in today's simulation. When you look down here at the send a message, you're sending it to router 2 person 0.14. It's coming from me, who is on router 2, and I am 0.9. So that is the router number, and that is my ID number, is the point part. All right. Once we are sending messages, you can open your log browser and look at the actual messages, and you can see, did the message send successfully? Who is it from? Who is it to? Who is the message? And which router handled the message? Okay, I'm going to stop sharing here for a moment and just go in to beautiful, let me, hang on, there. Oh, I know what's going on. Okay. So let me just see if I can escape out of this so that I can take us to, so when you go to code.org and you go into internet simulators and routers, you're going to hit this, puzzle 2 of 4, an updated internet simulator. Read through these first. This has a slide bar. It is going to tell you about how this router works, or how this simulator works. Many changes have been made. Rather than being connected to your entire class, you're now connected to a single router. I want you to read through this, understand how you're sending messages. The top portion of the message is the IP address, and then looking at your router stats. When you go in, it's going to be the same thing. You're going to pick period 2, which is now. You're going to join a section. There are a bunch of routers here. So you are just going to join a router. Start with the lower numbers just so that we fill these up. We want to have at least 3 people per router. So that's it. Go in, join your routers, and then we will start working on this. I'm going to go back to the presentation. So you can look at your messages. Okay, hang on, let me get back to, oh, actually we are still presenting. Oh, that's not what I want to hit. This is, are you still seeing me full screen?
Yeah.
Okay, so once you guys start sending messages, you can look at the messages, view all messages, including other routers, follow the activity guide, and answer each question below. We haven't. So what we're going to do, you're going to need to open your activity guide. Did you guys get that at the start of the lesson, or do you need to get it now? Here, let me escape out of here. So your activity guide is right here in routers and redundancy. When you open that, you're just going to go to the activity link. Here's your guide. We're going to the internet simulator. You choose a router. You need at least 3 to 4 classmates on your router. Find your classmate's IP address to begin today's activity. Explore the new version of the internet simulator. You'll likely notice that the structure of the messages has changed a bit to include the IP address for both you and the person you are sending the message to. If you look at the network visualization, you will find the IP addresses of your friends on the router. Use the new tool to get comfortable with the updated message format. Spend a couple of minutes in conversation. Choose 2 classmates on your router and exchange a short conversation with one another. Make sure your messages are getting through and that you're not sharing any secrets. You'll see why in a minute. Read the traffic. Move to the router tab and click log browser button and see the network traffic, then respond to the questions below. How many total messages? Okay, we're going to take about 5 minutes and work our way through this, all right? So you're going to get your activity. You're going to log into code.org. On the simulator, pick a router to get on. There's a 6-person limit. You will be investigating how messages are sent across the internet by checking router logs to track your messages. After you've completed this section of the activity guide on your own router, post your IP address in the chat. Students from other routers will be able to send you a message. You can also send messages to others finding their IP addresses. As you use the simulator, record what is happening on your activity guide. Okay, so I'm going to give you 5 minutes. So you guys are going to go in, you're going to send each other messages. Once you've done that, post your IP address in the chat and let other people send you messages and send messages to other people. Remember to answer their messages. Okay, is everyone in? Does anyone have a problem getting on a router? Let's see. So we've only got 4 routers and they're all full. That means we have 24 people. We have a lot more up there, 31. Okay. Is everyone on a router? Okay, off you go. I will start the timer. Okay, so we're going to finish this up right around 10:47. Okay, once you've sent your messages to each other, remember to post your IP address in the chat and let other people send you messages. I'm not seeing anything in the chat. Okay, is everyone getting this? Is everyone seeing that you've got multiple people? Let's try. No, okay, let's come back. Okay, what were people seeing? What was going on in there?
It was hard to keep track of who was sending you messages.
Hang on, Lily, I'm having trouble hearing you. What was that?
It was hard to keep track of who was sending you messages.
Okay, because it's just a little decimal number and you can't see the name.
Yeah, and multiple people are messaging you at the same time.
Right, right. Were all their messages getting through? Did you look at the logs?
No, they weren't.
Okay. So those are all things to keep in mind. We've got this, our new goal, use the router logs to choose an IP address from each of the other routers. Post your IP address in the chat, find classmates' IP addresses there too. Send each person a message asking who they are and choose one of the following questions. What's your favorite food? What's your favorite type of animal? What's your favorite color? be sure to respond to questions you get from other people on the routers. So when we open the router logs again, you should see a lot more messages. Now we're going to go back to looking at the activity guide, right? This is U4L4. You know, they're already asking questions like, how many total messages passed over the router? You can just guess. You know, it's just a guesstimate. About what percent of those messages did you actually receive? Pick an approximation. Did all the messages sent?
Hello?
Did Mr. Swift get disconnected? Oh no, there he is.
You're on mute.
Yay, I'm back. So what we were going over is these are the things that you're going to be ticking off during this exercise. You know, did all your messages go through? What messages have been, why might a message have been dropped? Can you trace a full conversation between your classmates? What types of things are people talking about? So find a classmate on a different router then. You can actually send a message to a classmate on different routers if you like. You just need to know their IP address. Everyone's posted them on the chat. Have a conversation with a classmate on another router. Read in the traffic in the same tab before click to log browser button again, then the show all routers button, okay? So let me just show you this. So when I'm in here in my router log, I'm showing all traffic and I'm showing my router. You can also click here and show all routers. And then you can see the log from everyone's router. So you can see, you know, we've got, you know, over 100 messages at least here. Okay, send those messages, and then we're going to come back in 10 minutes and we're going to talk about the kinds of things that we're seeing in the router logs and how you're answering your questions on your worksheet. Okay? Come on. Why is this doing this to me? Sorry, Synergy is pinging me. Okay, so let's get started. Anybody have any questions? All right, so we're going to start our 10 minutes. We'll be done at about 11:02, maybe 11 o'clock.
Sorry, I have a quick question. I actually can't find where all the router logs are.
Okay, so hang on. So when you go into your code doc, hang on, it's right on the left side. So let me get out of here. When I'm in my router, oh, that's a question. Can somebody abandon their router and join router 6? Because I'm in here and there's only two other people. They need at least 3. And I think it's just our numbers work this way. So when you're in here, beautiful, thank you. you click on router and then you click log browser. That drops you into the log of the router, and you can look at your own router only, or you can click it and make it show all routers. Does that make sense?
Perfect. Thank you.
No worries. It's always a little confusing when we're starting these out. That's really weird. Let's see more traffic. Nobody seems to be sending many messages. Weird. That's just a thing. I don't know why all our messages seem to be getting through. Normally messages should be being dropped. Everybody try sending messages all at once right now. There's a dropped. It's just weird. Every message seems to be success.
I'm pretty sure the drops happen if you send it to like an invalid IP address.
No, that's not what this widget's about. Okay, team, let's come back. Let me get back into. Okay, did everyone get through with their activity guide? Anybody not through with their activity guide? Please put it in the chat or let me know.
I'm still working on it.
Okay, so one of the tricky things is trying to track a message, and that's where this screen helps us a bit. Let me present this. So see how, like, I swear in our whole log, we only had one dropped. But you can follow a message. Does the message always go in a straight line from you to the person you're talking to?
No.
And are you only sending one message when you type in a message and send it? When you look at the logs? Like, did 6.12 send cool beans?
No.
Say 4 times. So something's happening here that also that this started out, if you look at the timestamps, you can go to the start of a message. So this started out with router 6 sending it to 5, but then it went to 13, then it went to 8, and then it finally made it to 5, where its destination was 5.5. Okay? So can you predict why some messages are appearing multiple times? Let's put this in the chat. Can you predict why messages are appearing multiple times when you only sent it once? Okay, do I need to pick on someone? Okay, they're saying it has to go to other people. They are not, they are sending from router 1 to 2, 2 to 3, because it has to pass through other people to get to you if there's not a direct path. What are some other reasons why messages might be appearing multiple times? I have a nice answer from Ian and Zoe. Anybody else? What's part of the internet? What's part of when Mr. Vint built the internet? What were they trying to build? Does anyone remember? The idea of a system that if a nuclear bomb went off, you would still be able to communicate. So there is redundancy built into the system. Sending multiple messages is a way to ensure that one of those messages is going to make it to the right destination. Okay, so of course our messages are being sent from router to router, bouncing between different routers in the network. Not all messages take the same path to get to their destination. In fact, even when sending multiple messages to the same person, messages may take different paths. Why is that? Okay, let's not go into this. We're just going to go into why is that? Can someone answer for me, either in the chat or unmute themselves? When sampling multiple messages to the same person, the message may take different paths. Why do messages take different paths? Remember our video? What does it look like inside a computer when it's sending messages? What's another similarity between computers and the US postal system? They all have to get, oh, go ahead, Dennis.
There's always different routes to the same destination, so looking for the fastest one.
Yeah, which route do you pick?
The fastest one.
But what happens sometimes?
It might get mixed up, or you might get slowed down.
Or you might get stuck in a traffic jam. And ideally, that is why some messages are not making it through, and there is a need for computers to send multiple versions of a message to ensure that one of them gets there. Tomorrow, next class, we'll be working on some of these issues. So what did you notice about messages you sent in the router logs? Did they always take the same path from your router to the other router? This is a pretty softball question based on what we just said. Can someone answer this one? What did you notice about messages you sent in the router logs? Did they always take the same path from your router to the other router? You can take a look right now. Here, let's go back. Since nobody's being brave, I'm going to go here and say, okay, so this message down here at the bottom went from 14.5 to 2.1 4 times. 14.5, 14.5, 14.5 to 2.1. That did not take a separate path. This one, no, this is 6. Oh, here, that's right. No, so never mind. I'm looking at the wrong thing. So this didn't either, that it was going 14.5 to 2.1. It went to 6, it went to 8, and then it made it to 2. So these are taking different paths, and it's not like people were saying, it's not going 1 to 2, 2 to 3, 3 to 4 down the line. It seems a little random, right? So let's look at Cool Beans. Cool Beans went from 6 to 13 to 8 to 5. This is Lily. It went from 13 to 7 to 8 to 6. It's taking it like 4 hops to get there. Okay. Let's look at, these are vocab words that we're going to be focusing on and coming back to. You might need to know for the AP. A router is a type of computer that forwards data across the network, across a network. So a router is a type of computer that forwards data across a network. Redundancy, the inclusion of extra components so that a system can continue to work even if individual components fail. For example, by having more than one path between any 2 connected devices in a network. So if one device fails, there's another path the information can take to where it needs to go. That means there are redundant paths, paths that do the same thing. Fault tolerant. Fault tolerant means it can continue to function even in the event of individual component failures. This is important because elements of complex systems, like a computer network, fail at unexpected times, often in groups. So our 3 words are router, type of computer that forwards data across a network; redundancy, the inclusion of extra components so that a system can work if individual components fail; fault tolerance, system will continue to function even if in the event of individual component failures. Okay, thinking about these terms, router redundancy, and fault tolerant. How can we describe what we've observed in the computer logs at the end of this activity? What are practical reasons that you think messages might take different paths from one router to another? Okay, hang on, can someone answer this who hasn't answered a question? Or you can type it in the chat. So try and use router, redundancy, and fault tolerant to describe what we were seeing in the logs and what are some practical reasons you think messages might take different paths from one router to another. All right, I'm going to start picking. Oh, look, there's somebody I haven't talked to. Rory Brookhart. Rory, can you help me and just try and describe, how can we describe what we've observed in the router logs at the end of this activity, given the terms router, redundancy, and fault tolerant?
Okay, so what it seems like is routers use, well, it's called router redundancy. So they send a message on different paths. Like, so say 2 people are trying to send a message to the same IP address. Both of those messages would take different paths to get to the same IP address to prevent their messages being lost.
Okay, and what is that? What is sending multiple messages?
Isn't that called router redundancy?
Well, it's redundancy, but yes, that's, it's router, comma, redundancy, and fault tolerant. So routers are providing redundancy to the system by sending multiple messages. Routers are not technically redundant in and of themselves. And what is the fault tolerant part? So say one router goes down.
Yeah. So it's kind of what we learned last week. Like if you sever a connection, you have to make sure your system is still able to operate correctly. Has
alternate pathways, and
Yeah.
those are the redundancy. So fault tolerant is that a whole piece of this system can go down and the system will still survive. So the idea that a nuclear bomb lands on one of our routers is not going to stop our messages. If my message was in that router when it was blown up, I've already got a couple other messages in the system, and we'll learn in our next class how computers can actually ask for messages they didn't get. So great job, Rory. What are some practical reasons you think messages might take different pathways from one router to another? How about Sabine Zaman? Can you handle that one? Sabine?
What was the question again?
What are some practical reasons that you think messages might take different paths from one router to another?
Possibly to figure out if there's a quicker route.
Right. That it's part of the redundancy is it has to send messages on different paths, but the reason it's sending on different paths is the idea that there might be traffic on one path, a bomb might have landed on the router at another path, that you need multiple messages in the system to ensure that one of them gets to your destination, and that they take different paths because one path might be blocked or one path may be slower than the others. Okay, so let's just go over this. We're almost done. Actually, I think we are done. A router is a type of computer that forwards data across a network. Redundancy is the inclusion of extra components so that a system can continue to work even if individual components fail. For example, by having more than one path between any two connected devices in a network. And fault tolerant, can continue to function even in the event an individual component fails. This is important because elements of complex systems like computer networks fail sometimes and often in groups. And typically it's Murphy's Law or the corollaries. They fail when you really need them. You know, Murphy's Law is that anything that can go wrong will go wrong. The corollaries are anything that can go wrong will go wrong at the absolutely worst time for it to go wrong. So we are done. This is the warm-up for lesson 5. You are free. I am stopping sharing. If anyone has any questions, they can hang out.
Thank you so much.
Yay, we made it through lesson 4.
Thank you.
Thank you.
Okay, just get those sheets in by next class. Hi, Juan.
I wanted to talk to you about the test.
Sure.
Yeah. So you said that I could take it today or like Wednesday?
Yeah, ideally today is better, but we can do it on Wednesday if you have to.
Yeah, could we do Wednesday?
Okay. Thank you for asking. You could just email me too.
Oh, all right, yeah.
So Wednesday, it is going to be on the new Zoom link I sent out to everyone at our check-in time, which I believe you are period, oh no, you're period 2.
Yeah.
So that'll be 10:30.
All right.
For you. So it's 10:30 to 10:50. I'll give you the test and you'll have a half hour to do it. The test shuts itself down.
All right. Thank you.
Okay, no problem. Get that worksheet in. Do you have any questions or problems with what we've been going over?
No, I'm fine.
You sure?
Yeah.
All right. No, I'm just so excited to get with you and get you back up to speed because I know how it just doesn't make you feel good when you're feeling behind and like you're not really understanding. So I really want to support you.
All right. Thank you.
All right, my friend. I will see you at 10:30 on Wednesday.
All right. Yeah, I'll see you.
Okay.
All right,
Remember, just check the check-in time.
Yep.